Hi everyone, welcome to lecture number 5. Now today we are going to discuss structured approach to system requirements. So today's topics actually concentrated on entity relationship diagrams and data flow diagrams. Now this is what we are going to learn today. So we'll first try to understand the meaning of structured and object-oriented approaches to system analysis. What is the difference between these two? And then we will move to entity relationship diagrams. You know that when you design a new system, we need to model the objects in that particular system. So we use entity relationship diagrams to model these systems. You already understood or you already learned the main concepts for entity relationship diagrams in your INF20015 unit. So we will going to touch the basics in ERD diagrams. And then we are going to move into the data flow diagrams. We call it as DFDs. So what do you mean by a DFD? Why we use DFDs? This is what the main focus in today's lecture. So we are going to basically cover three main topics. Now let's go through the difference between the traditional or the structured approaches to system analysis and object-oriented to system analysis. Now, traditional and object-oriented approaches to system development actually differentiate how the system's response to an event is modeled and implemented in the system development projects. Now, basically, traditional approach views a system as a collection of processes. So, some processes are performed by people and some processes are performed by computers or the applications. So traditional computer processes are much like procedural computer programs. They contain instructions that execute in a sequence, one after another. When the processes executes, it interacts with some sort of a stored data, and it reading the data values and then write these data values back to the data files or entities. So the process might also interact with sometimes with the people, such as when the instructions ask a user to input a value or it displays information to a user on a computer screen. So traditional approach to systems then involves processes, it involves some sort of a stored data, it involves inputs and outputs, and it also includes processing models that emphasize these sort of system features. So you can see in the left hand side of this diagram the basic features in traditional system analysis activities. Then let's go to the object-oriented approach. Now, object-oriented approach actually views a system as a collection of interacting objects. So the objects are based on things in your problem area. We call it as problem domain. So objects are capable of having behavior. So we usually in the programming languages we call it as methods. So these methods allow them to interact with each other, so each objects, and with also with the people using computer applications. Uh, so one object probably ask another object to do something by sending a kind of a message. So there are no conventional computer processes under object-oriented approach, object-oriented models, or we don't use any data files, or we don't use any databases. Now object carry out all the activities and remember the data values. So when modeling what the system does in response to a sort of an event, the object-oriented approach includes various models that show the objects, their behaviors, their interactions with the other objects. Uh, so basically, when you model system requirements, the traditional and object-oriented approaches to requirements modeling probably employ different models, right? So different models. So we will learn the different models in these two approaches in coming weeks. Uh, Right. So this is what basically we are trying to um, going to learn in these 2 weeks time. So we are going to learn the left hand side of this diagram. So last week or week 4 in lecture 4 I have discussed some basics in system analysis like events, use cases, user stories, and how you're going to create an event table, right? So these are the basics which actually relevant to both traditional and object oriented approaches. Now today what we are trying to do is we are moving into the left hand side of the diagram. So we will try to understand the things in our problem domain or whatever the problem that we are trying to solve. So what do you mean by the thing? So how are you going to understand or how are you going to discover this so-called thing? So things means the entities, right? How are you going to understand, how are you going to discover these entities? So you can see, you know that already in your INF20015 unit, we already given you the entities and the attributes. But in real life, when you go to some sort of software development project environment, you need to discover these things or the objects or real life objects. How are you going to discover these real life objects? So that is what we are trying to learn today. And also we are trying to actually go through some basic concept related to the entity relationship diagram, and then we will move to the other models in structured analysis. So that is what we are trying to learn today. So we are not going to cover everything because traditional approaches or structured approaches cover in 2 lectures. Now today I will do the basics, and next week or week 6 we will move into little bit of a detailed description of the other structured or traditional models, as you can see in this particular diagram in the left hand side. Uh, then we will move into the week from week 7 and week 8 we will going to do the other side of this hierarchy, or in other words we will move into object oriented approaches to system analysis once we have finalized the structured approach. So that is how we are going to do our learning in these coming weeks. Things in the problem domain. Now what do you mean by the things? Now usually when as you learn in database analysis and design, we use data entities to represent objects. So data entities are what the end users or the users deal with when they do their work. For example, they are working with products, they are working with sales, they are working with shippers, they are working with maybe shipments when it comes to our Ridgeline Mountain Outfitters case study, and also they are maybe dealing with customers. So these are often referred to as things in the context of the system's problem domain. So what do you mean by the problem domain in the system analysis? So we often use this term. uh, so the problem domain is the specific area of the user's business that included within the scope of the new system. So in your case, probably now you are designing the subsystem. So that is one of the specific area of your case study you are focusing on. That may be the problem domain in for you. So the new system involves working with and remembering these so-called things. For example, some information systems need to store some sort of an information about customers and the products. So it is important for the business analyst to identify all the important information about them. So often things are related to the people who interact with the system or to other stakeholders. Um, for example, a customer is a person who places an order, but the system needs to store information about the customer. So the customer is also a thing in the problem domain. Um, so there are so many techniques for identifying important things in the problem domain that the system needs to remember. Now, two of them are introduced in today's lecture. So the first one is called the brainstorming technique, and the second one is called the noun technique. Now, what do you mean by the brainstorming technique? So we'll come to that more detail a little bit later on. Now, when you know that when you use the use cases, the business analyst should ask the users to discuss the type of things they are work with routinely. The business analyst can ask about several types of things to help to identify them. Different type of things are important to different users, so it is very important to involve all types of users to help identify problem domain things. So the brainstorming technique is used to identify problem domain classes, or the things where the developers work with the users to identify different types of things that they use in their day-to-day work. So the second important technique is so-called noun technique. So the noun technique, actually, if you recall correctly, a noun technique, a noun is a person or a place or anything, right? So therefore, identifying the noun might help the business analyst to identify what needs to be stored by the system. So we need to begin by listing all the nouns that the users mention when talking about the system. Now nouns used to describe probably events. Nouns may be used to describe use cases. Nouns may be used to describe user stories, and the actors are potential, and also other actors also are the potential things as a noun. So noun techniques actually try to identify nouns, right? So this is what they mean by the noun technique. So let's come to brainstorming technique little bit more in detail. Now this particular figure 5.3 shows some type of things to consider that can be used to system actually to help to do some sort of brainstorming. So we can actually have a kind of a prepare this sort of list before we go to brainstorming session. Tangible things are often the most obvious things, such as probably airplanes, a book, or a vehicle. So when it comes to our case organization, Ridgeline Mountain Outfitters, a product in the warehouse and probably a vehicle in the fleet are the tangible things which is very important for the business analyst. So other common type of things in an information system is probably the different roles played by a person, such as an employee, a customer, or doctor, or a patient. So the roles of customer is obviously a very important one for our Ridgeline Mountain Outfitters case study. So many things in the problem domain can fit into more than one type sometimes. For example, if you think about the vehicle might be thought of as a device, and also it can be a tangible thing. So either way, the important point is to identify all the potential things in the problem domain. So other type of things can include some sort of an organizational unit, such as a particular division or the department or even a work group, and also a site or a location such as a warehouse, a store, or a branch office. So might be an important things that we can consider in a system. Now sometimes information about an incident or interaction can also kind of a thing. For instance, information about an order, information about a service call, information is about a contract or a airplane flight. So all these are the kind of an incidents or the interactions that we need to keep remember in our system. A sales or a shipment and return are all the important incidents for our Ridgeline Mountain Outfitters case organization. So sometimes these incidents are thought of and kind of an association between different other things. For example, a sale is an association between the customer and the item of an inventory. So initially the analyst might simply list all these things and then make some sort of an adjustment as required by different approaches to analysis and design. So the business analysts identify these type of things by thinking about each use cases, talking to the users, or and asking a question from some stakeholders. For example, if each use case, what type of things are affected that the system need to know about, store information about. The type of thing shown in this particular diagram or the figure can be used to systematically brainstorm about what type of things might be involved in each use case. So when a customer wants to buy something from the website, the system need to store the information about the customer, the items ordered, the details about the sales itself. So such as the date and the payment terms and the location of the items uh, to be shipped. So for that one use case, the business analyst can define tangible things like item ordered, role played something like a customer, an incident or event something like a sale, and sites and site or a location something like a warehouse, an organizational unit like a shipping, right? So these are the things that you need to consider when you're trying to brainstorm the things. So brainstorming technique is very comprehensive technique. Now let's go through the steps that we can follow when using the brainstorming technique. So first we need to identify a user, a set of use cases, or even a set of user stories. Uh, then brainstorm with the users to identify things involved when they're carrying out the use cases. That means things about which information should be captured by the potential or the system that we are trying to develop. And then use the type of thing or the categories that I have listed in earlier diagram to systematically ask questions about some sort of potential things, such as are there any tangible things you store the information about? Are there any locations involved? Are there any roles played by the people that you need to remember by the system? So likewise, you can ask various type of questions related to your the things that you have recorded, and then continue to working with all types of users and stakeholders to expand and the brainstorm the list that you have created. And then finally what you can do, you can merge all these results, and if you see any duplicates, eliminate these duplicates, and then compile the initial list of uh, things in your problem domain. So these are the basically 5 steps that you can follow to identify things in the problem domain. Right, then let's come to the noun technique, little bit more in detail. So the noun technique is a technique, as I told you earlier, is a technique used to identify things in the problem domain by finding and classifying the nouns that it comes in your discussion with the users. So that any descriptions you have found in the documentation. So noun is any person, it can be any place or anything. So so therefore when you identify these nouns, it might be very helpful for you to identify what needs to be stored in the system. So we can begin it by listing all the nouns that users mention when they're talking about the potential system that they like to develop, and noun used to describe events, use cases, user stories, and the actors are the potential. Also the actors can be a potential things as well. And then we can add the list, add to this list any additional nouns that appear in the information about existing system or that come up with probably discussion with stakeholders about the problem domain of the system. The list of noun probably will become very quite long, so the list will need to be a bit of trimmed and refined later on. So how the noun techniques differs from the technique that I have defined earlier, that means the brainstorming technique, is that the business analyst list all the nouns without thinking too much about them, and without talking about them with the users. So only the later will the list will be refined, and based on the consultation with the stakeholders and users you will come up with the things. So this is basically a kind of a systematic, very popular technique to identify the entities and the attributes. Uh, mm, the main problem with the noun technique is sometimes we need to probably trying to avoid these synonyms sometimes. So same meanings that come up with the discussions. So sometimes we may have confusion about whether this particular thing is an attribute or is it actually an entity. So we need to careful about that as well. So the noun technique is very popular when there are no users available to help to brainstorm. So in some project probably this is one of the popular ways to identify uh, entities and the attributes. Uh, in this particular diagram, business analysts who are working in our uh, system analysis project has identified different nouns and made this list. So and also usually it's a good practice to keep some notes, including when you include these nouns. For instance, this particular business analyst captured the noun called accounting. So he has a problem. So in the notes section, uh, what he said here is we already know about the accounting, so we don't need to store about it. So actually the accounting, so the word accounting or the object accounting, we need not to store in our uh, system. So probably the system we are developing at the moment is consolidated sales and marketing system for our ridgeline motor. So the business analyst think, right, we don't need to store that information in that uh, particular system. And then he also come up with a noun called backcode. So there were in that particular backcode noun, then he have a puzzle. So he recorded like a question: is it a special type of order, or it is a value of order status? So do a bit of research, right? So this is the note that he has written in his notebook. So what he will do once he has done all these refinement, he will go through the notes and see what kind of nouns that he need to do bit of research further. Probably he may ask stakeholders or users to have another discussion, and maybe he or she can clarify about these nouns later on. So likewise, this business analyst for the Ridgeline Mountain Outfitters project has come up with some sort of list of entities by identifying some potential nouns. Right, so what are the steps that we can follow when using the noun technique? First step is when using the use cases, actors, and other information about the system. Be come up with the inputs and the outputs. Identify all the nouns, so it can be everything. Now, when it comes to our Ridgeline Mountain Outfitters case study, consolidated sales and marketing system. So the business analyst, as you said, as you saw in the previous example, perhaps included all these nouns: customers, product items, sales, confirmations, transaction, shippings, banks, blah blah blah. So everything has included uh, in his list. Then step number two, not so relying on the other information from the existing system, and then going through the current procedures and current reports or the different numerous forms. Maybe we can add items or add categories of information needed into this list. For Ridgeline Mountain Outfitters consolidated sales and marketing system, these might include more detailed information such as prices, sizes, colors, styles, probably different seasons, inventory quantities, payment methods, and shipping addresses. Some of these items might be additional things, and some might be specific information. Probably we can call it as attributes about things. So you already have identified. So then we can refine the list and then record the assumptions or issues that we need further explore, as you can see, you have seen in my previous slide. Then then in step number three, now when these list of noun builds, you as a business analyst we need to refine it. So ask some sort of a questions about each noun to help you to decide whether you should include it or whether you should exclude it, or whether you should do some bit of research. So these are the questions that you should ask, whether to include, exclude, or the research. So likewise you can actually get some potential information regarding things. And then once you have done that, we can create a sort of a master list of all the nouns that we have identified, and then note whether each one should be included, excluded, or researched further. And then finally we can review the list of things with the users and the stakeholders, and also with the team members, and then refine these list of things in the problem domain as a finalized uh, entities and attributes in your problem domain that you need to include in your system. Entity relationship diagrams. Now, when it comes to structured approaches to system development or traditional approaches to system development, now these structured approaches actually place a very great deal of emphasis on data requirements for a new system. And they often use the term data entities for the things about which the system needs to store the information. Now, these data requirements include data entities, their attributes, and their relationship. So we usually call in in database or the system analysis domain these relationships as associations. So usually we use the UML language, UML notations. So in the UML notation, we call it as associations among data entities. So the brainstorming technique and noun technique described in this lecture earlier are used the same way with the data entities as with the domain classes used in the UML modeling later on. So usually we use the entity relationship diagram in structured system analysis domain to construct databases. Now remember, entity relationship diagram is not the unified modeling language diagram, but it is frequently used and is quite similar to the domain model class diagram that we will going to discuss in our object-oriented analysis. Uh, so there are no really standard notation, but you can actually adapt your in database analysis and design subject notations if you wish to develop an ERD diagram for your case organization. So this is an example of an entity relationship diagram notation. Please recall your knowledge in database analysis. Now this simple ERD shows you two entities, and then the relationships between these two entities, and also cardinalities like one and many cardinalities between these two entities. So we have custom entity and we have the odd entity. What does it says? One customer may enter or may have many orders, or actually we can call it as one customer can place zero or many orders, right? So zero many orders, or the other way around, one order must relate with one customer. So that means that the foreign key which goes to the order entity is a not it's kind of a not mandatory, right? So that is what they mean by this diagram. So the cardinality symbols, as we discuss in our database unit, uh, we can use these cardinality symbols to model our relationship. So this symbol is called the mandatory, right? So we call it exactly one. So again, this relationship called optional relationship. It actually shows you a zero or many. So we can have zero or many instances related to this particular primary key in this entity. The foreign key can be zero or more in the related entity. That is what they mean by this. And then we have optional participation, um, and then we can have one or more type of one mandatory participation. So we haven't learned this actually in our database analysis and design subject, but this is another way that we can model our domain model diagram, so entity relationship diagram. So this example actually give you a sort of a idea about entities and attributes. So we are using UML type of symbols to model entities. So we have custom entity, we have order entity, and we have order line item entity. and each entity has set of attributes, and we have identified the primary or the main key for each entity. So remember that when you're deciding a primary key, it has to be unique, right? So you need to find out what are the unique key, what is the unique column that related to each of these entities. So one customer uh, may have zero many orders, and one order must contain at least one or many order line items. And if you go back the other way around, one order line item must related with one order, and one order must related with one customer. So that is how this entity relationship diagram discuss or interpret. Then there is another example here in figure 5.8. This is another example. In this case, we have four entities for four objects that we like to uh, represent in database. So customers, accounts, and branches, and transactions. So transaction is, it's an event that we need to capture and record as a data entity. So one customer must have one or many accounts, and one account must belongs to one branch, right? And then one account type must have one or many or transactions. So if you go other way around, one transaction must belong to one account, and one branch may have many accounts, zero or many accounts, and then one account must belongs to one customer. So that is how we read this diagram. So left to right and the right to left. We need to go through this diagram in order to identify the key relationships. Use cases and CRUD technique. Now, CRUD technique is an acronym for create, read or report, update and delete. Now, this is the technique we use to validate or refine the use cases. Now, CRUD technique, which involves verifying all the needed use cases that have been identified to maintain the data represented by our entity relationship diagram. So CRUD is as I said, we use is an acronym. So acronym for create, read, and report, update, delete. It is often introduced with respect to database management. Now, basically, the business analyst first start by looking at the type of data, the objects or the things or the entities stored by the system. And now, if you think about the Ridgeline Mountain Outfitters trade show system, as discussed in my lecture 1 or the week 1, type of things of data maybe include suppliers, contact details, the product information, product pictures. Then when it comes to the consolidated sales and marketing system, the things might include the customers, sales, inventory items, promotions, shipments, and many other things. So to validate and refine the use cases, so business analysts look at each type of data and verifies that a particular use case have been identified that create the data, that read the data or report on the data, update the data, and delete, or we can call it as archive the data. So the CRUD technique is most useful when used as a cross-checking along with a user goal technique, as I described in last week. So users will focus on their primary goals, and use cases that update or archive data or delete data will often be overlooked in these kind of discussions. So the CRUD technique makes sure all the possibilities are identified. Sometimes these entities may be shared by set of integrated other applications. For example, Ridgeline Mountain Outfitters have a supply chain management application that is responsible for management inventory levels and also adding some products. So Ridgeline Mountain Outfitters consolidated sales and marketing system will not need to create or delete products in that system, but it will need to do a search or update product information. So it is important to identify the other applications that is responsible for creating, updating or deleting the data, to be clear about the scope of each system. So that is the usefulness of CRUD technique in system analysis, to rectify and cross-check the use cases in your system. Let's go through the data flow diagrams. Now, data flow diagrams is a graphical system model that shows all the main requirements for a information system in one single diagram. It contains the inputs, it contains the outputs, it contains processes, and also data entities. So usually we call data storage rather than data entities. So everyone working on the development project can see all the aspects of the system working together at one single data flow diagram. So that is the one reason for why it is so popular in today. And DFD also very easy to read because it is a graphical model, and also it has only 5 symbols to learn. Uh, so end users, management, and all the information system workers can typically read and interpret so-called data flow diagram with very minimal training. So that is why data flow diagrams are very popular tool to model and structure our systems requirements. So let's go through the data flow diagram symbols. So these are the 5 symbols we are going to use in data flow diagram when you're designing the data flow diagram. Uh, so we have this process symbol in the top. The process symbol actually in a DFD represents sort of an algorithm, or we can call it a procedure by which data inputs are transformed into data outputs. So it's sort of a process. We are showing the processes using this diagram or this sort of a symbol. And then we have this so-called data flow. In this arrow we show the data flows of data. So this arrow represents the data movement actually among the processors or among data stores and among so-called external agent, which represent in this particular box. Uh, then we have this symbol is external agent. External agent is any person or any organization outside the system boundary, right? So always remember, external agent always outside the system boundary, that supplies data inputs or accepts data outputs from our systems, right? It can be a person, or it can be another system, or it can be another organization, depending on the system you are going to model. So the external agent is always a source or maybe the destination of the data outside the system, basically. And then we have this sort of a symbol. This is actually the data entity in our entity relationship diagram, or we called it as data store. This is where the data is held pending for future access by one or more processors, right? So these processors accessing data from these data stores or entities. Uh, and then we have this so-called zigzag kind of double-headed arrow. This is shows you the real-time link. So this actually shows you the communication back and forth between external agent and the processes when the processes start executing. For instance, sometimes when when you execute something, we need to check credit verification from an external body. So how you going to represent that link with the external body with the organization process? We use this zigzag type of double-headed arrow to show. I think these symbols you can find it in any business application or drawing application like VCO or Draw.io in freeware version. So these are the UML models we are going to use to model our data flow diagrams in this semester's project. So before we move into modeling using data flow diagrams, so let's go through an example of an event table that the business analyst has created for our Ridgeline Mountain Outfitters. Now this is an existing system or old system, customer support system, the event table created by the business analyst. So customer support system is a system that we are going to get rid of, and then we are coming up with a new system called consolidated sales and marketing system. So the existing system, these are the system events that captured by business analysts using an event table. So they have identified basically 4 events for the customer support system, and then as a part of this particular event table, they have identified uh, use cases or activities that responded for these events. So one of these use cases, look up the item availabilities or search item availability, right? So if the customer wants to check some item, so that is the event, and there is a trigger, so customer actually inquire about the item. So source is the customer, so this is the external agent, and then we have the use case, and then this is how the use case responded by sending item availability details back to the customer. So how are you going to capture this information in data flow diagram? Right, all these now if you think about each row contains one specific event, so that event has so many details that we can capture using data flow diagram. So let's go through one example of a data flow diagram. Right, so for this diagram, actually we can create a number of small data flow diagram. We can call it as uh, data flow fragments. So one fragment for uh, each record or each event. So this is an example of data flow diagram. So in other words, this is actually a data flow fragment for the one event. So we have the external agent, right, the customer. So external agent is the source as well as destination. If you go through our event table, you can see the source and the destination is both the customer or the external agent, right? And then we have this lookup item availability use case. So how are you going to model it using a data flow diagram? This is how we're going to model. So we have the process symbol, right? So look up item availability. So we have the external agent, because we are not worrying about the customer's processes, so they are external, so they are supplying some item inquiry. So we shows the item inquiry using an arrow. So arrow is heading towards to the process, so it comes inside the process. What comes inside the process is this data. So data is item inquiry. So actually that data captured in the trigger, right? So that information comes inside to the process. The use case is the process, and in order to execute this use case, the system need to capture some information from different entities. So in this case, uh, for in order to execute this small fragment, business analysts determine we need the catalog information, we need product item information, and we need inventory item information. So we are going to read from each of these entities back to the process in order to produce the list of available items back to the customer. So this actually small fragment shows you the all the required information for that particular fragment in our event table. So we have external agent, and then we have it's the source, and then the trigger is this information coming in, and then the use case is the process, and then we have data stores, and then the response goes back to the external agent. So the external agent is a destination in this case. So we captured the information contained in this particular fragment or this particular record using in data flow diagram notations. So therefore data flow fragment is the smallest component in our data flow diagram, right? That is a smaller data flow diagram that we can draw in our system. So if in your event table, if you have 6 events, you can actually develop 6 fragments in your project for your project. So we create the fragment for each use case, for the list of events that contain in the event table. Now each fragment actually represent the system responses, right, for a one single event, by using one single process symbol. Now when it comes to fragment, we can actually test to show that it has a kind of a self-contained model, because it will not getting any data inputs or produce output for any other systems. It's the smallest self-contained model that you can draw in your system. So it focusing on the attention to single part of the system. Yes, so it shows you how what will happen if you execute one single use case in your system. So single use case is a smallest. Sometimes it may can be very complex sometimes, but we usually it's the smallest abstracted level of process in your system. And also this fragment shows you entities required in your use case execution. Data flow diagrams and levels of abstractions. So many different types of data flow diagrams are produced to show system requirements. The example just I described is the data flow fragment showing one process in response to one event. So other data flow diagrams show the processing at maybe very high level for more general view of the system, or at lower level or more detailed view of a one process. So these different view of the system, high level versus low level, we usually call them as levels of abstractions. So data flow diagram can show either higher or lower level view of the system, The high-level process on the data flow diagram can be decomposed into separate lower level, more detailed level data flow diagrams. So process on the detailed data flow diagrams can also be decomposed into additional diagrams to provide multiple levels of abstractions. Context diagram. Now a context diagram in data flow diagram actually describes the most abstract view of the system. So all the external agents and all the data flows we recorded into one system. So we have all the data flows into and out of the system are shown in a one single diagram with the entire system represented as a one process. So it's actually kind of a bird's eye view of the system. Uh, so it actually shows you the boundary of the system or the scope of the system. So in your project, probably each individual designing one subsystem. So your subsystem, whole subsystem can be shown in a one single context diagram. So as I said you earlier, so we represent one single process and all the external agents and all the data flows in a one single diagram to represent this context diagram. So let's go through one of the example of a context diagram. So this is an example of a context diagram for Ridgeline Mountain Outfitters customer support system. So remember the event table that we have created for customer support system. So this is the event table, and this is the context. This is the subsystem that we created using that event table for the customer support subsystem. So the context diagram usually created in parallel with the initial list of use cases and the events as you saw in the event table. So each trigger for an external event become an input data flow and the source become an external agent. Each response become an output data flow and the destination becomes an external agent. So triggers for the temporal events are not the data flows actually. So there are no inputs data flows for the temporal event in the context diagram. So in this case, you can see in this example, we have how many external agents. We have credit bureaus, merchandising department, management, shipping department, accounting department, bank, customers, and marketing. So basically there are 1, 2, 3, 4, 5, 6, 7, 8, 9 external agents associated in the subsystem, and each of these external agents are supplying some information and getting some information back from the system. And you can see this what do you call this real link between the credit bureau and the customer support system. So credit information goes back and forth with the customer support system and the credit bureau. And remember, when you name these uh, data flows, always remember to use the nouns. For example, in the marketing department actually supplies promotion and package details to our customer support system, and then back from the system they are getting prospective customer activity reports, right? So that is how we model our context diagram using these symbols. So this is one of the examples that we can use to understand the meaning of the context diagram. The second type of data flow diagram that we can construct is called the event partition system model. Sometimes we call it as diagram 0. So usually we create this diagram 0 by combining all the data flow fragments for a given system or the given subsystem. into one big huge diagram. So if you combine all your fragments that you have created for your event table, and then you can create the so-called diagram 0 or event partition system model. So diagram 0 is used primarily as a presentation tool. It summarizes the entire system or the subsystem in a very greater in-depth detail than the context diagram. So, however, sometimes business analysts often avoid developing diagram 0 because the content duplicates the set of DFD fragments. The diagram is often very complex and very complicated, and particularly for the larger system that respond to many events, very difficult to model and show it in using a one diagram. So basically we use as a presentation tool to show the whole entire system processes to the stakeholder. So let's go through an example. Now imagine we are trying to develop a course registration system for a university. Now imagine we have created a event table which consists 3 events, and then we have identified 3 use cases. So based on these use cases, the business analyst have developed 3 data flow fragments like this. So the first fragment is schedule courses, and it has a one it identified one external agent which supplies scheduling data. So this data is processed and goes to data entity. So it write back to the scheduling information to entity called offered courses. And then the business analyst has identified a second use case using an event table. So enroll students. So that particular use case associated with an external agent called a student. So a student supplies enrollment requests, right? And in the process of the use case supplies back scheduled information back to the students. So in order to process this student enrollment information, the business analyst determined, right, we need 3 entities. So we need to read some details about the students from the student entity, and we need to read information about offered courses information, and then we need to write an entry into the course enrollment entity, and then the schedule details goes back to the students. So that is the process, or that is the use case we are talking about here. And then the business analyst identify a third use case called producing the class list, or produce class list. So the external stakeholder is the faculty member. So produce class list probably is a kind of a temporal event. Each semester or each teaching period, we need to produce a class list to the faculty members. So there is no data input, but the system itself need to produce time to time the class lists back to the faculty member. So business analyst in this case has determined that we need 3 entities in order to produce the class list. We need student information, we need offered course information, and we need course enrollment information. So we need to read data from each of these 3 entities in order to produce the class list. So the business analyst has constructed these 3 fragment or data flow fragment for the 3 events that he has identified. So then the next step is we can actually create based on this information, we can create diagram level 0 or event partition system model. So when you combine these 3 fragments together, we can actually develop this diagram zero model. So you can see in this diagram zero, it contains all the information that you have listed in these three fragments. So we have three external agents, so we have three processes, and then we have three entities, and also it shows you the data flow movement. So academic department supplies the scheduling data, and we enters the scheduling data for this offer courses entity, and then student enrollment will process student enrollment details and supply that schedule back to the student. In order to process that, we grab that information, offered courses information, and then we read from the student, and then we write it back to the course enrollment data. And then at the end of the semester, or the time, I mean middle of the teaching period, or whatever the time period, the system is going to produce a class list back to the faculty member. So the logic that represented in these three fragments we captured in the diagram 0, or event partition system model. So that logic need to be represented very carefully and clearly in this diagram 0. Right, so this particular diagram shows you how to decompose the data flow diagram models. So first we create the context diagram, so that is the bird's eye view of the system. So in our previous example, this is the course registration system. We are showing it in a one single process, and there are three external agents involved in the course registration system. And then based on the fragments that we have created, we can actually decompose the system into diagram 0, which combines all these three fragments. But sometimes some fragments involve lots of processing details, so processing steps that the business analysts need to explore more in detail. So as with many modeling steps, if you have a complicated kind of a uh, uh, fragment, we need to further decompose it in order to understand and learn more about the requirements, in order to produce some documentation. So in this case, this example, so business analyst has determined the the fragment schedule course is a bit complicated, and he or she has actually divided that into a further down level, or further uh, another DFD. So that is called actually a diagram 1. In this case, diagram 1 means that is a further decomposition of the first fragment. So you can see the first fragment actually consists of another sub-processes. So scheduling courses involve, first we need to choose days and times, and then we need to assign the faculty members, and then assign the rooms, right? So now when you decompose it further down a particular fragment, make sure you capture the logic. Now the logic in this sense, if you think about this particular process, you can see one external agent, that means the academic department involved with this particular process, and then one data flow goes back to the entity called offered courses. uh, so we need to show that logic. So academic department actually supplying, now scheduling course data or scheduling data means it has the course information, it has availability, faculty availability details, so availabilities of faculty member details. So that is what do you mean by the schedule data. So in this, business analyst captured this into separately identify into two separate flows in this case, and then identified, right, there are three processes inside the scheduling course. So the course detail goes to sub process, choose days and times sub process, and then once you process it, date and times will return back to the offered courses data entity, and then availability of staff detail goes to assigned faculty use case or sub use case, and then that is also recorded in offered course. So that means this particular sub or the use case contain three subroutines, I would say three subroutines, right? So choosing days and times, assigning the faculties, and assigning the rooms. So this particular entity is not actually shown in the high level diagram 0. So you can actually show that uh, additional entities in this refined or the most low abstract level of data flow diagrams. So let's go through another example. In this time we are using Ridgeline Mountain Outfitters subsystem. Now why we have created this subsystem? Because if you try to create a event table for consolidated sales and marketing system, so you may ended up with 100 or 200 events. So rather than creating a big system, we divided the event table according to similarity and based on the subsystems. So each subsystem actually have maybe 10 or 20 or events and associated use cases. For the Ridgeline Mountain Outfitters, so they have identified these four subsystems: order entry subsystem, order fulfillment subsystem, customer maintenance subsystem, and catalog maintenance subsystem. So each subsystem, they have identified the use cases and the events associated with each of these subsystem categories. And then they may have done a kind of a CRUD analysis. So this is the CRUD analysis table, as I said earlier. So constructing this table actually shows all the data entities and all the use cases, and find out what are the missing use cases that we need to include further by going through it, because each uh, column actually shows you the entity and the associated use case. So if something is missing, for example, in the catalog column, you can see there are reads, there are updates, there are creates instances, but there is no uh, delete something, right? So the business analyst may find out, okay, let's make a use case to delete an instance in the catalog, right? Because we need to delete something, or we need to archive sometimes the information in the catalog database. So we need a use case to look after that particular aspect. So likewise, the business analyst may have refined the events, and the use cases may have come up with the different sets of use cases. And then the business analyst has designed this uh, context diagram for order entry subsystem. So order entry subsystem, if you go back, uh, is the first subsystem here. So this is a subsystem we are going to develop now using data flow diagram symbols. So yes, so we have identified 1, 2, 3, 4, 5 use cases, and then this is the subsystem we represented. It's a context diagram. So 1, 2, 3, 4, 5, 6. There are 6 external agents associated in this particular subsystem or entry subsystem. And then for each uh, yeah, for each use case. So we have here 1, 2, 3, 4, 5 use cases in order entry subsystem. So the business analyst has developed 5 data flow fragments. So first one is searching item availability or lookup item availability, as we discussed. Then we have create new order use case. Then we have update order use case. Then we have produce order summary reports. Then we have produce transaction summary reports. Now you can see there are numbering systems there. So it's basically arbitrary numbers you can give. So there is no kind of, it's not showing that we need to execute process 1 then process 2. It's not that. Actually it's a number that we try to put to identify each of these uh, uh, use cases. So the fragments clearly. Right, so then based on these fragments, uh, business analyst has created this event partition system model low diagram 0. So we need to combine 5 fragments together. So this is what they have come up with. So you can see if you go through this process number 2, create new order. So you can see there are lots of information go back and forth from this particular process. So the DFD fragment number 2 actually involves lots of processing steps probably. So we need to understand more little bit detail, so it's much better we decompose further the create new order use case, because it looks like a bit complicated, and also updating order has sort of another complicating process, but that is very straightforward, updating order. But creating new order looks like, because we have lots of other external agents also involved. uh, so once we created this diagram 0, uh, the business analyst has actually decided to further decompose this second process or second fragment, create new order bit in detail. So this is the inside of process number 2. So these sub-processes are numbered 2.1, 2.2, 2.23, 2.4. But the numbering system, as I said, it doesn't necessarily imply the sequence of sub-process execution. The diagram decomposes the process 2 into 4 sub-processes. So what are these 4 sub-processes? You can see the record custom information sub-process, record order sub-process, process order transaction, uh, then we have produce confirmation. So these sub-processes are viewed as 4 major probably steps required to complete the create new order use case. Uh, so this decomposition is just one way to divide the work. Probably another analyst might arrive at a different solution. So it depends on how the business analyst approach for the decomposition. Now if you go through this diagram, the first step begins when the customer provide the information making up of a new order data flow. So then the new order data flow contains all the information about the customer and the items the customer wants to order. Now if the customer is a new customer, then the process 2.1 store the customer information in the entity name the customer, or that means it creating a new customer record or updating the existing customer information as required. Now remember that the entity represent the customer data entity on the entity relationship diagram that we have discussed before. Now then the process 2.1 actually sends the rest of the information about the order, probably a data flow name, the order details in this diagram, onto the process number 2.2. Then the process number 2.2 takes the order details data flow and then create a new order record by adding data into the order data entity. Then each item ordered, the stock on the hand and the current prices are searched in the product item and the inventory item entities. Then if the adequate stock is on the hand, an order item record, a kind of a record is created, order, we can call it as order item record for that particular item, and the stock on hand of the inventory item record is changed accordingly, right? So if say for example if 3 items are ordered, one order record is created and then 3 order item records are created. Remember the ERD diagrams we created in database diagrams, database analysis and design unit. We have one order with many order line items. So in this case, if they order 3 items, we create one order with 3 line items, right? And then the process 2.2 adds up the total amount due for the order. So how they calculate that? Maybe they may multiply the price with quantity for each item and then sends that data flow name transaction details to the process number 2.3 to record the transaction. The transaction include probably the order number, the amount and the credit card information, right? Then the process 2.3 needs a kind of a real-time link to credit bureau to get a kind of a credit authorization for the customer's credit card. So this need to be a kind of a real-time link rather than a data flow, because the data needs to flow back and forth rapidly while the process is executing. So if the credit card is approved, a record of the transaction is created in the order transaction data entity, and the data flow for the transaction then goes directly to the bank. The final process produces the order confirmation for the customer, and the order details goes to the shipping department. So using the order number, process 2.4 look up data on the order or search data on the order, the customer, and each order item, right? So it looks all these 3 tables plus also the item description and the product items as well, and then produces the required output. So this is how the process looks like for new when you break down the fragment, create new order into a smaller sub processes. So likewise in your project also think about how you're going to break down so complicated fragments into smaller fragments. So this ends today's lecture, lecture 5, and I think now you have a kind of a clear idea the symbols that we use in data flow diagrams and what kind of diagrams we are trying to produce in a structured analysis. So we learn the context diagrams, we learn event partition system models, and then we learn the data flow fragments, and then we know how to further decompose the fragments if it is too complicated. So you can apply these concepts into your project. Now you can start building your fragments by using the event table. Thank you.